So I'm pleased to introduce our next speaker, Pulin Desai. He is the Director of Product Marketing at Cadence and focused on Tensilica DSP product line. So with that, Pulin, welcome.
Thanks, everyone, and welcome to my talk parts. But I see some familiar faces here. So as you said, my name is Pulin Desai, Product Marketing Director for Vision DSP IP at Cadence. So within Cadence, there are various businesses, and I'm part of the Tensilica IP group. And Tensilica was a company that Cadence acquired about 6 years back. And the main product that Tensilica was offering was our Extensa processor. It's a 32-bit RISC processor that our customer can use as a main controller. And one of the unique things we offer is TIE, Tensilica Instruction Extension. And with this, our customer can write and add their own instruction set and create a custom solution for whatever problem they're trying to solve. And this allows you to add, as I said, a new instruction. And that business continues to be there, but on top of it, we took the same concept of TIE, Tensilica Instruction Extension, and we created vertical product lines for digital signal processing for different market. One of the market we target is audio DSP. Our Hi-Fi DSP is our #1 audio DSP solution for audio decoding, also for voice processing or wake-up word processing. I'm part of the Vision DSP group, and over here, our Vision DSPs get used for imaging and computer vision processing, AI on the edge. And then we have a product line called Connex. That's a communication product line that can be used for radar, LiDAR, or a baseband modem. And overarching all this thing, we have another product line called DNA 100 that stands for Deep Neural Network Accelerator. And this Deep Neural Accelerator can be used for CNN, RNN, and regression. So as I said, I'm part of the Vision DSP, so I will be now focusing on the Vision DSP products. So we believe the image sensors are driving the huge market for Vision DSP. Our business is to provide Vision DSP, and we believe that wherever there's an image processor, there's an opportunity for us to sell a Vision DSP. And this image processor market is growing at 12% CAGR from 2018 to 2025. Some of the growth is coming from the mobile market, about 8%. The biggest growth is coming from automotive market, about 36%. And the rest of the markets like AR, VR, security cameras, drone and robotics, the CAGR is growing at about 12%. So our Vision DSPs are targeted at various of these markets: AR, VR headset, automotive, drones and robotics, mobile and surveillance camera. So here, what I'm trying to do is showing you some of the market trends, some of the applications, and where the vision processing gets used and for what the vision processing gets used. So one of the market trend you see in the AR, VR market is the number of cameras are increasing. You already have 4 to 6 cameras. In automotive, at some point we will see close to 20 cameras. In mobile, we all have cell phones and we have used it where you have the front-facing camera and the rear camera. You usually have 2 cameras, but now it's moving maybe 2 cameras in the main or maybe 3 cameras in the main. So you're gonna have at least 3 sensors or the four sensors. The other thing is that in all of this application, this processing, our customers are looking for, the application they're looking for is in real time. And that also want to achieve something in video process, in the video rate. You might also see a much higher field of view cameras in some of this application. So some of the applications, those are driving this. So if you look at the AR, VR, I have not listed everything. There's some high level thing. In AR, VR, you might see eye tracking, gesture recognition, inside-out tracking. In automotive, we basically have 3 different cameras, in-car monitoring or driver monitoring system, There are all other cameras to do any kind of autonomous navigation or path planning, and you might have cameras to do 360 view. In mobile, we have been using our cameras to take pictures, to take selfies, but then we have already been using them for face recognition or object detection. Maybe you can use it for measurements. You could use for night shot. But the new application that people want to use is AR map. And we'll talk more about what we mean by AR map. Now, in order for some of this application type of vision processing our customers are looking for, as I said, the large field of view, you might have some de-warping application. If you're trying to do 360 view, you need to do stitching of these images. You will need vision processing for a night shot. So you might do some noise reduction for that, or you might do some other processing to create a night shot. Even other things happening in the mobile market is a multi-sensor computational photography, and that requires vision processing where you have multiple cameras are being used to take images. And then one other main thing we see is HDR, high dynamic processing, and we all have gone through this thing where we have taken the picture, the bright light behind you, then my face becomes completely dark. Or another situation, maybe you're trying to use this camera for some path planning where you're driving on a bright road, an icy road where you need some kind of an HDR processing. And the other places where the vision processing is used is SLAM, simultaneous localization and mapping. And next slide, we'll talk more about what SLAM stands for. So as I said, SLAM stands for simultaneous localization and mapping. And it's a technique used in robotics, drone, mobile, and automotive markets to automatically construct or update a map of an unknown environment. SLAM is also used in AR/VR market for inside-out tracking. Now, if you take a look at the processing that's required in SLAM, this is a classic computer vision application, and it is a heavy linear algebra matrix operation. And today, most of the time when you're running SLAM, it's running on either CPU or GPU. CPU, you won't be able to get the performance. Remember the real-time performance that we were looking for. It will be also giving you higher power consumption. You can run it on GPU. It'll give you higher performance, but it won't. It will burn a lot of power. So where does it get used? So here's one example of a potential use of this one. So this is an example of AR map, right? So we may all have used mapping application to take a direction in a large city, walking direction. We want to go from one place to another place, and I always use it, but I usually get confused because you're in a new city, unknown area. You don't know which direction you should be going. It'll tell you go northeast or southeast. There is a blue line on it. And until you start walking, you don't know if you're going in the right direction, you're going in the wrong direction. So for that, an AR map can be used for a visual positioning. And in this situation, this picture actually was taken in Buffalo, New York. And with the camera, it was able to, it can find the city hall of Buffalo, New York, and it recognizes, okay, there is a Niagara Center, a Niagara Circle there, and in front of that, there is a Pearl Street there, and now it can give you all the necessary direction using the AR map. Now, same kind of a AR map can be used for direction inside for a navigation assistant. So you're at a large mall, and usually I'm completely confused where to go, how to find a store, and navigation assistant can help you. Or you could be at a large airport like a Heathrow or Chicago airport, and a navigation assistant can help you to find a specific gate. And these are all the things that we can do with the cell phone. But then when you're using that with a cell phone to take a direction and walk with this thing, usually somebody like me will run into somebody, or I might get killed. So maybe in the future you will do that with your AR glasses. So regardless of whether you are doing with the AR glasses, whether you are doing with the mobile, the most important thing in order to do something like this, you need a low power, high performance solution. So last few slides I've been talking about vision processing, but at the same time, I'm also going to talk about AI processing. So to simplify, the AI processing for inferencing, we have segmented the market over here in 3 different segments. At the low end, you see half a teraMAC type of a performance requiring. In the middle range, maybe 1 teraMAC to the 4 teraMAC type of performance required. And for higher end, you might need tens or hundreds of teraMACs. And these are all for inferencing application. And the point over here that one size doesn't fit all. Depending upon what market you're trying to do, you're going to need different processing power. So this slide, I'm trying to again come back to the Vision DSP and how the Vision DSP fits into the camera pipeline. So if you see on the left-hand side in the classic bare sensor, the bare pattern is there. You could have 1 sensor or 2 sensor. And after that, depending on what you're trying to do, but some customers may use our Vision DSP to do noise reduction in the bare domain. So bare noise reduction would be one of the application our customer may do. After that, you usually have an ISP. And ISPs are going to be most likely on most of the application going to be hardwired, because that's something that we've been doing for 30 years. But you could have, instead of a bare pattern, or something different pattern like RGB IR, where some of the pixels, the 1/4 of pixels could be near IR pixel. Or instead of the bare pattern, you might have a different pattern where instead of 2 green, you might have 2 white pixel, or one of the green is a white pixel. And over there, our programmable Vision DSP can be used. And after the ISP phase is the next phase where the programmable Vision DSP can be used to do 2D, 3D noise reduction. Remember the night shot I talked about where you might use the 2D, 3D noise reduction, high dynamic range, super resolution, image stitching for the 360 degree, or even just with the 2 camera. And a SLAM would be the another thing one would run in the post-processing. And after that is the AI processing, where the classification, segmentation, whatever happened to be your favorite AI application you would run. And that can run on a Vision DSP, or it can run on a dedicated AI accelerator. So this hopefully gives you a good understanding of all the stuff we are trying to do. Now I'll switch on to our Vision DSP. So Tensilica Cadence has been in the Vision DSP market for over 5 years. And Vision P5 was one of the DSP we announced in 2015. And in 2016, we introduced Vision P6, which was the first Vision plus AI DSP from Cadence. Last year, we announced Vision Q6, where we provided 1.5x performance over Vision P6 for Vision plus AI. And this week, last Wednesday, the press release was done. We announced Vision Q7 that offers 2x performance over Vision Q6. So what is Vision Q7? Vision Q7 is our 6th generation Vision and AI DSP. It's a follow-on to highly successful Vision Q6 DSP for Vision and AI. It offers up to 1.7x higher performance, higher tops in the same area, delivers 1.82 tops. Up to 2x performance for Vision and AI application, including floating point performance, and up to 2x gigamax per mm square and gigaflop per mm square. So this slide, we're showing you some of the kernels that shows the performance on Vision Q7 relative to Q6. So we ran some AI kernels, some SLAM kernels, and some Vision kernel to show you that how the Vision Q7 performs compared to Vision Q6. So in terms of the performance improvement, we looked at 3 different areas and improved on 3 areas: the Vision improvements, AI improvements, and floating point improvements. For the Vision, we focused on SLAM, and with the Vision Q7, we are offering up to 2x performance on SLAM kernel with specialized ISA and special SLAM package, and we'll talk more about that in the next stage. We also offer 2x multiplier and accumulator, 8x8 and 16x16, that can be used for the Vision. And I also added more specific instruction set to improve the performance. For the AI, the 2x 8x8 max. So in our Q6 product and on the P6 product, we had 256 8-bit MAC, and now we are offering 512 8-bit MAC and 128 16-bit MAC. So that's doubling compared to our previous generation. Now, when we're talking about AI inferencing, most of our customers are using 8-bit fixed point processing, but then in some cases, they are also interested in the half precision floating point number if they want more precision. And for that reason, we double the half precision floating point performance on the Q7. And the floating point, I already talked about half precision floating point, but we also double the single precision floating point performance on our DSP. So other thing is that Vision Q7 is backward compatible to Vision Q6. So it's source compatible. So our customers who have already invested in the software for our previous generation can easily bring their architecture or their development on the Vision Q7. Now, if you remember, I talked about TIE, Tensilica Instruction Extension, and with that, that Tensilica Instruction Extension is available on Vision Q7. So with that, if customers still want to add more specific instruction to solve a specific problem, then that can be done. Now, till now, I've been talking about computational performance, but when you're doing imaging and AI, there's a lot of data movement going on. You're moving large data from image sensor to the DDR memory to the local memory of our processor. And for that, we offer an integrated DMA. And we have improved the integrated DMA by providing a 3D IDMA. We have also added data compression on IDMA and 4 channels on the DMA. Now, we are in the automotive market. We are providing IP so that our customer can develop SoC for the automotive market. And for that, we provide IP and tools. Those are designed for ISO 26262 certification. Our customer can develop SoC that will get the ISO 26262 certifications. And on top of that, our customer can add a TIE instruction while maintaining the ISO 262 certification. So earlier I talked about SLAM. Let's come back to that. And we looked at the SLAM and said, okay, what are some of the main blocks? So it could be different sensors you have, but then the first block is the key point, and then the rest of the are for the pose estimations and bundle adjustments. So when we analyze, we realize that the key point detection is mostly done in fixed point. And the rest of the stuff is usually done in single precision floating point. So that's why we improve the fixed point performance, and we improve the single precision floating point performance by doubling the single precision floating point, and we added hardware package and a linear algebra function. And on top of all this, we also added a SLAM library optimized for Vision Q7 DSP. So this is a high-level block diagram of the IP that we provide. This IP sits on AXI. It has multiple AXI interfaces. We also have we call a local memory or a tightly coupled memory that called data memory. We also have instruction memory and instruction cache, and then optional scalar data cache. Now, coming back to the AI, the earlier when I was showing you the 3 different segments that the one would need, for the AI market. So with the Vision Q7 and the DNA 100, our neural network accelerator, our AI processor, we can basically provide solution for the whole market. The Q7 for the low end of the market, and the Q7 plus DNA 100 can address the higher end, mid to the higher end of the market. Now, depending upon level of performance you're looking for, some of the customers can use our Vision DSP in multi-core situation. The multiple Vision Q7 can be used, or a multiple Vision Q7 with a DNA 100 to create a Vision and AI platform. So until now, I've been talking about hardware IP. Now, hardware IP has no value if we don't provide the solution. So we also provide AI software platforms. On the left-hand side, you see is a neural network compiler. So this neural network compiler can take Caffe, TensorFlow Lite, and give you highly optimized code for our Vision DSP in the fixed point, 8-bit fixed point. So now our customers don't have to develop the code from scratch. We also offer Android Neural Network API for those customers who are utilizing Android as their platform. So last slide, I talked about the AI software. Now I'll be talking about the vision software stack. And for customers who want to use high-level language, we provide OpenCL, we provide Halide, and we also offer OpenVX. But at the same time, large number of customers will use embedded C, C++. And for that, the most important thing over there, it says OpenCV-based imaging library. We call it Extensa Imaging Library. And we provide over 1,700 functions. Those are highly optimized for our Vision DSP. And with that, the customer can start their development. Now, while we provide the software stack for both AI and Vision, we also work with a large number of software partners who have their own Vision and AI algorithm and also are expert at programming our DSP. And these software partners are in various geography, whether it's China, US, Japan, Europe. And with this, we basically provide complete solutions of IP, software, and application. So in summary, our Vision DSP and AI processor summary. So the market, we believe the market needs both Vision DSP and AI processor. Image processing and vision processing requirements are increasing, and that's because of the new experience our customers are looking for, higher resolution coming in the market, and large number of sensors. Those are being used in all these devices. And another thing is that any SoCs, those are being designed for all this market, usually have multiple hardware blocks. There is going to be a CPU, there's going to be GPU. In some cases, there's going to be a hardware accelerator block, and the Vision DSP and an AI accelerator. In the Vision Q7 DSP, we offer up to 2x Vision AI and SLAM performance compared to Vision Q6 DSP, deliver 1.82 teraops, 1.7x higher compared to our Q6 DSP in the same area. Complete Vision software, library, OpenCL and Halide, and then complete AI software platform, ANN, Tensilica Neural Network Compiler, to meet the market need. So if you want some more information, you can go to ip.cadence.com and you can find all the information about our DSP. If you want to get into very technical detail of SLAMs and lots of equations, then my colleague, Dr. Srinivas Gadkari, will be presenting at 4:20. And thank you very much.
Can you shed some light from your customer's product point of view, what pixel per frame and frame rate they have achieved with your product?
So, well, I mean, different markets have a different pixel resolution and different frame rate requirement. I mean, frame rate, you need minimum 30 frames per second, but the resolution will be different from market to market, right? So the mobile phones have much high resolution for the standard image camera versus in automotive or surveillance, maybe only 2K or 4K maximum, and depending upon that. So that's really depends on the market.
Can you give an example of the high-end side?
Example at what?
What's the pixel per frame and the frame rate?
For which market?
Any market. And give
well, so like the surveillance cameras are 2K or 4K at 30 frames per second or 60 frames per second, yeah.
Any other questions? Please step to the mic.
Thanks a lot for your presentation. I would like to know what happens if we use the infrared sensor, because most of their architecture is based on visible, so Bayer decoding, RGB, and so. Can we bypass them, or what is possible?
So what kind of sensors are these?
Infrared, thermals.
Oh, thermal sensors. So I'm not very familiar with the thermal sensors, so I don't know what's required for the thermal sensor. So I don't know how to answer that question.
But can we bypass the inputs, the Bayer decoding?
Can you bypass what?
In the
diagram that I had?
Yeah.
So the diagram that I was showing you was for a classic Bayer sensor, where you have a Bayer sensor and then you are doing ISP, because that ISP is doing Bayer to RGB and RGB to YUV, a type of processing. Thermal sensors, I don't know. I'm not very familiar with it.
Maybe we can do a fusion. Little bit of
Please step to the mic.
You can answer
We
that.
can't hear you.
So I work closely with Pulin. So we can certainly imagine going forward there will be a fusion of imaging and something else like thermal sensors or time of flight, and definitely the marketing is gravitating in that direction.
Thank you.
Okay, any more questions?
All right. Thank you, Pulin.
Thanks. Okay, thanks.
Thank you. Great job.